Let's talk about modeling. You're probably familiar with models, like a weather model that will predict the path of a hurricane, for instance. A model is basically a mathematical representation of predictive performance. We're going to be looking at green roof modeling. Hello, I'm Brad Garner. I manage software and data for Green Roof Specialty Products and also for Green Roof Diagnostics. These two companies are working together on producing a green roof hydrologic modeler in an effort to improve performance standards throughout the industry. So first we'll look at how the model works. There are basically 6 major functions that proceed in sequence. This is a continuous flow hydrologic modeler. There's a little bit of information about the project, and then there are equations. All the equations and parameters are listed at the bottom of the page with references and links. So we enter the model through here. Currently we only select a location and a date for historical weather. The weather is pulling up actual historical weather from a given year, but that will be replaced with a stochastic weather generator in the next version. So what are we looking at? There are 2 horizontal bars in the center. The top one is temperature. It goes from blue, cold, to red, hot. If we hover, we can see what the specific weather was for the date that we just hovered over. The bottom one is humidity, that goes from green, wet, to yellow, dry. These are 2 of the major variables that affect the performance of the model. And then the third one, the more prominent one up at the top, is rainfall. And here you can see this goes from no rain up to 2 inches of rain, or slightly more than 2 inches of rain. If we hover this one, we are at 2.28 inches of rain. Snowfall also shows up as precipitation on here. And so those are the 3 major factors that affect the model. Then the predicted performance is down at the bottom. So these 2 bars and what's on top is weather. Performance is down on the bottom. There are 2 things that we are showing on the graph for performance. One is stress. So this is when there is limited water available to the plants and they begin to exhibit stress. And then the other one is runoff. And you can see the runoff always corresponds with rainfall. There are 3 dashboard graphs down here. This one shows rain and runoff in inches. I should note we can change the whole thing over to metric as well. So rain and runoff, we have precipitation, total evapotranspiration, which is the same value as retention. Everything that is retained is evaporated. And then what is not retained runs off. Then we have a dashboard graph for days with stress level. So we have 155 days with no stress, 51 days with very high stress, which would be these and these. And then we have days with runoff. So there were 92 days with some runoff, but less than half an inch. And these are the other days. So we don't have any days where we have high volumes of runoff. Well, we have 2 days where we have 3 inches of runoff. So that's actually quite a lot. Those are some things we'd be really interested in reducing. And so what is this a model for? Well, when it first pulls up, there's a baseline of a 4 inches of soil, no mineral wool, no detention layer. We can change these toggles, and it will tell you if you hover what these are. We can change these toggles, and we can say do less soil, and we can see that runoff increases, stress days increase when we have less soil. We can add more soil, and then we see another color on the graph where we start off with the baseline when the page loads. We have 4 inches in neither of these. That's our baseline. And then with all the other graphs, we compare against the baseline. So you can see we've reduced runoff, we've reduced stress against the baseline by adding more soil. So there's more volume retention and a deeper rooting zone. We can add a little bit more soil, and we see that change. So let's add 1 inch of mineral wool, and we can see the change that that has. 2 inches of mineral wool. We can add a detention layer, and we can check these and see what the sensitivity of the different layers is. So that is as good as we get with this assembly in this location. You can see there's one part of the year where we still do have a good bit of stress after limited rainfall and a significant amount of heat. So currently this is a comparative tool that is meant for just a comparative analysis. This is not intended to be used for a permit application, but we are working on improving the program, and we're very interested in talking with civil engineers and hydrologists to figure out how this concept can help you with your green roof designs. Thank you.